Dear participants, delegates, and organizing committee members of the 8th International Conference on Contemporary Engineering and Technology 2020. Greetings from Botswana and a very good day to one and all present here. I am Suresh Shanmugasundaram, professor from Boto University, Botswana, working in the Department of Engineering under the Faculty of Engineering and Applied Sciences. I would like to take this opportunity for inviting me to do this keynote address. It always gives me immense pleasure to have this kind of conversation, and 99% of the time I say yes when I am invited for such episodes. Please accept my apologies as I could not make a physical presence due to the international travel ban that was laid because of the coronavirus outbreak. I had to cancel my tickets in the very last minute. I request you to be safe by maintaining a good hygiene to mitigate the spreading of the virus. I also take this opportunity to congratulate the organizing committee members and the technical committee members for planning and executing such a kind of a technical forum. Okay, let me start with my address, the actual purpose of being here. Before that, I would like to present to you the outline of the session. Firstly, it will be an introduction of the country where I am currently residing, and then it will be the introduction of the place where I'm working, which is called Boto University. Then we will see what is engineering and technology and their impact on sustainable development. We will also be seeing some examples of engineering sustainability. Since my area of interest is in distributed framework, I will also be providing few examples relating to computers. And finally, we will be touching upon the roles of engineers in sustainable development, followed by a brief summation by highlighting further reading as well as bibliography which was referred. Okay, let me briefly introduce you to Botswana. I will not be surprised if I get a wrong answer if I ask you, where is Botswana? This is because I was also ignorant about the geographical facts of Botswana. As some of you might have guessed, Botswana is in Africa. To be even precise, the Republic of Botswana is a landlocked country located in southern Africa. Citizens are referred as Botswana, and the singular form of it is called Motswana. It is interesting to note, as per the list of per capita nominal GDP for countries and dependencies, Botswana ranks 76th in the world by the nominal GDP per capita, which comes to around 7,584 US dollars. Just to give a comparison, India is ranked 139th. Please note that there are 10 districts, with the southern districts majorly populated. About 86% of the country's income is from diamond mining. Yes, the country is very rich and the population is too low, which is about 2.3 million. In terms of the country's vision towards education, the government felt that education and development are indispensable, and hence the students are sponsored to pursue tertiary education and higher education. When I say sponsorship, it includes tuition fees, living expenses, and allowances for buying books and stationery. Just to give you more perspective on the country, I have put these pictures. While the urban areas are growing at a very good pace, the country still maintain its closeness to nature. The northern part of the country has about 300,000 elephants. There is a unique feature when it comes to Botswana's border. In the northern side of the country, there is a border called Kazankula. At Kazankula, the territories of four countries, Zambia, Botswana, Zimbabwe, and Namibia, come close to a meeting at a quadripoint. In fact, I have visited the quadripoint, which is located in the river. Another interesting point is that this river, which is called the Zambezi River, is the main source of Victoria Falls. I would like to take an opportunity to invite you to this country. It will certainly be once in a lifetime experience. The university where I am working is Botho University. Botho University is Botswana's largest private tertiary educational provider, and it was founded in the year 1997. We have established campuses in other countries like Lesotho, Namibia, and Eswatini. We also provide programs in the distance learning and blended mode. In the picture, you are seeing the aerial view of the Habaroni campus, lecture halls, graduation ceremony, and a shopping mall called Game City, which is at a close proximity to the university. You will also see the flags of Botswana, Namibia, Lesotho, and Eswatini, which is formerly known as Swaziland. I hope you had a chance to appreciate Botswana and Botho University. Now, the images that you see here represent something. I would say that in all the images, you can observe a process that involves design or production of things. It could be from any discipline or could be any product. There are definitions that are available for engineering as defined by IEEE, ABET, etc. However, I always like the simple ones. It goes like this. Engineering is the use of science and math to design or make things. Technology is the application of scientific knowledge for practical purposes, especially in industry. You can see the difference between engineering and technology, though they seem like same. To make it more clear, engineering is the use of science, technology, and math to design and make things. Nowadays, the term sustainable development is getting its focus. In this image, you'll be able to see many ways of achieving sustainability. You see a solar panel that provides not just energy, but sustainable energy. The energy that's produced from renewable energy sources never deplete the natural resources. So let us define sustainability as avoidance of the depletion of natural resources in order to maintain an ecological balance. In a normal scenario, we can also say it as ability to maintain itself. You might think before 30 years or so, engineers were making things without concerning sustainable development. Then why has it gained importance in the recent times? The answer is simple, and you will be able to appreciate by looking at this chart. In the year 1960, the global population was about 3 billion. In 2010, the global population is around 7 billion. In 50 years, the growth is manifold. By 2050, it is projected to reach about 10 billion. When there is a growth in population, there is a huge demand that keeps on growing, which eventually pushes towards more production. The process of production certainly depletes the natural resources, and just think about the future generation. They will be left with little or no resources like water, air, etc. To overcome this situation, it has become important for engineers to put more emphasis on sustainable development. Then comes the question of how to maintain or achieve sustainability. The answer is again a simple comparison on what we were doing and what we should be doing and when we should have started this. We all should agree that we have started this late and we have to resolve this, and this is clearly depicted in this picture. We can have a specific comparison of what we should be doing to achieve this sustainable development. For example, our focus now should be to prevent pollution rather than mere cleanup. Likewise, it applies for all that are listed there in the table. It is always good to have a clear guideline, especially when it comes to sustainability. Sustainable Development Goals are a collection of 17 global goals set by the United Nations General Assembly in 2015. These goals, right from zero hunger to partnerships for goals, are clearly set by the United Nations, and of course, each nation will be able to prioritize these goals depending on their needs and challenges. You would have seen in the recent times there was a ban in India to use plastic bags, spoons, straws, and other one-time use plastics. The same was implemented in Botswana as well. From this, it's evident that the SDGs set by United Nations play a vital role in achieving these goals. Now, we as the professionals gathered in this forum have an important responsibility to find ways of achieving these goals. I assume we are a forum that has a budding engineer to a mature scholar, and we will be certainly engaged in some projects in the near future. Some of us might already be engaged in such projects. Our responsibility towards sustainable society will be partially achieved if we deduce the research objectives or problem statement from the SDGs. If you are an academician, do not hesitate to direct your students towards these SDGs, even if they are doing a mini project. With this, we will certainly be able to work towards achieving a sustainable nation. By having this preamble, I believe we should be able to appreciate sustainability in engineering and thus identifying innovative ways to accomplish this. Let me quote a well-known example of computer recycle, or you can even consider recycling mobile phone devices. Sustainable engineering is the process of designing or operating systems such that they use energy and resources sustainably. In other words, at a rate that does not compromise the natural environment or the ability of future generations to meet their own local needs. The primary aim or objective to recycle the electronic gadgets is to prevent pollution, manage waste effectively, and thus contribute towards achieving SDGs. You can see that this will help us to move towards pollution prevention, waste prevention, less resource waste, and environmental restoration. In the next slide, you will be seeing more examples that you might be familiar with. This typically shows that use of renewable energy such as wind and solar. Innovation can also be seen where the car park is covered with solar panels. That means that there is no need of extra space to install the solar panels. Since my area is in the discipline of computer engineering, I would like to show you exemplifications related to computers. In this picture, you are seeing a bundle of wires. This is nothing but a skeletal representation of computer networks. To establish a simple network, you can see the usage of plastic insulation tapes, copper wires for the cables, which certainly depletes a certain amount of resources even for a single node. Then came the era of wireless networks. This picture shows where we were in the recent times in terms of computer networks. The computer networks became the backbone for distributed computing, and internet became the backbone for grid and cloud computing. This evolution in terms of computer networks played and is still playing a vital role in sustainability. In the slide, you are seeing a typical scenario of a laptop user. You can easily relate this to your everyday work. The scenario can be split up into multiple discrete tasks. For example, if you see the first activity, it comprises of Tom logging in his laptop, and then he opens up Google Docs to type his progress in his PhD work. Similarly, the entire scenario can be broken down into multiple tasks. In this table, you will see that each individual tasks are mapped onto one or more specific concepts in computing. The first task that you see is Tom logs in his mission. Clearly, this comes under the concept of standalone authentication if we presume that a laptop is not connected to a LAN domain. The second task, where he opens up Google Docs to type the report, is the application of cloud compute, where it uses software as a service. Similarly, there are platform as a service and infrastructure as a service in cloud computing, but let's park them for now. The next three tasks can be mapped to concurrency and multitasking, and finally concurrency and distributed computing. The three schematic representations denote distributed, grid, and cloud computing respectively. A computing system in which services are provided by a pool of computers collaborating over a network can be referred to as distributed computing. A service for sharing computer power and data storage capacity over the internet is grid computing. Finally, cloud computing means storing and accessing data and programs over the internet instead of a computer's hard drive. All the three are critical and are considered as vital technological framework to attain sustainability. In one of the previous slides, I was referring to software as a service. Other real-time examples that I could quote for software as a service are Amazon.com, Google Compute, Gmail, SAP, Dropbox, etc. And for platform as a service, the best examples are Google App Engine, Microsoft Azure, Microsoft Anega, Dropbox. And for infrastructure as a service, Salesforce.com and Dropbox are well-known examples. Now, a well-known example, Facebook, is a kind of tricky to relate to the above frameworks because Facebook is a consumer network product, not technically software as a service, but there is no other product that provides as many services as Facebook does. This up arrow clearly shows up that we have been moving towards achieving sustainability in the areas of computer networks and distributed computing. While this is not unusual global practice, I would also like to cite the overall perspective of distributed systems in Botswana. There was a detailed research conducted in the year 2014 to study the perception of various stakeholders in Botswana. The study pertained to distributed computing, more specifically to grid computing. The hypothesis of the study was that there was a very little or no research work pertaining to distributed computing was happening. As it was informed from the study, a common misconception that prevails in the nation is that grid computing is used only by the scientists for their research and no common man can use it in their daily routine. I thought sharing this information is vital in this forum as you can see bigger opportunities both in terms of undertaking a development project or research project in Botswana. Personally, I would be interested to collaborate with delegates here to undertake joint activities. If you see the characteristics of both grid and cloud computing, like increased collaboration, work from anywhere, they align closely to the SDGs by minimizing the resource usage and cost. That means there will be a lot of challenges that has to be addressed. Some of the challenges that are highlighted here arise due to the requirement of coordinated resource sharing, problem solving in dynamic multi-institutional virtual organizations, collaborative problem solving, resource brokering strategies, and term specification of resource providers and consumers. Now, when each of this is addressed through a detailed pertinent study, which is also listed in this slide, it is certain that an attempt to attain the SDGs will be made. The interesting part is distributed computing not only works in a single discipline, it could actually get amalgamated with other disciplines or areas like energy, smart cities, human computer interaction, agriculture, satellite engineering, and communication systems. This means that a scholar or an engineer who pursues such a study or a project must be skillful and innovative. For being an adroit, an engineer must be able to appreciate the fact that most engineering achievements of the past were developed without consideration for the social, economic, and environmental impacts on natural systems. Now, it must be primary mandate to look at the broad picture and thus be able to balance between affluence and technology. For an engineer to design or develop a product that has a minimal wastage and has a positive societal change, he or she must ensure that their knowledge about sustainable development is up to date, be prepared to influence the decision maker for a project, identify all the issues and options to the decision maker about projects of that decisions are soundly based, identify options that take account of economic, social, and environmental outcomes, ensure that offered solutions or options will contribute to sustainability, and be aware that there are inherently conflicting and unmeasurable aspects of sustainability. These qualities help professionals like us not to be followers like you see in the herd of sheep in the slide, but to be a leader with innovative thoughts. With this, I conclude my address. I recommend the articles shown for further reading. And finally, I would also like to show the list of references which are the main source of information for this presentation. Like I had mentioned already, I would be happy to get any questions emailed to me, and my email ID is src_suresh@yahoo.com. Once again, I thank the committee for this wonderful opportunity, and I would convey my best wishes to the other presenters and participants, and I'm sure that you will have memorable event ahead. Stay blessed. Hope to see you all in a different forum, in a different place. Thank you.